Hi there everybody, this is lesson 3.1.1. For this video you're going to need the 311 resource page that I gave you in class the other day. So if you don't have that out, go ahead and take that out now and pause the video.
On the table.
And so far in this class we've talked about three different transformations. We've talked about reflections, we've talked about rotations, and we've talked about translations. We're going to start this chapter with the fourth and last transformation, and that's called a dilation. You may have heard that word dilate before, maybe in terms of your pupils dilating. When your pupils dilate, they get bigger and smaller. And that's what happens when you dilate a shape. It gets bigger or smaller. And here I'm going to show you how to dilate a shape on a coordinate grid. Huh? So we're going to dilate this with a scale factor of 2. Okay, and that's an arbitrary number. We could pick anything. We could pick 1/3 or 5 or 10 or 2/5, whatever we wanted. But we're going to choose 2 for now, so you get the hang of it. And we're going to use the origin as the center of dilation. So the origin is the center of dilation. We're going to dilate it with a scale factor of 2. And that just means that all of these points get twice as far away from the origin being 0, 0. So in order to get to A, you need to go to the right 3 and up 2. Right 3 and up 2. But when you dilate it with a scale factor of 2, you go twice as far. So you're not going to go over 3, you're going to go over twice as far, which would be 6. You're not going to go up 2, you're going to go up twice as far, which would be 4. And that is where point A prime will be, where A ends up after the dilation. To get to point D, you have to go right 1 and down 2. But when you dilate it with a scale factor of 2, you go twice as far. So you don't go right 1, you go right twice as far, which would be 2. And you don't go down 2, you go down twice as far, which would be 4. And there is D prime. To get to C, you go left 2 and down 2. But again, we're going to go twice as far. So instead of left 2 and down 2, we're going to go left 4 and down 4. Again, twice as far in each direction. In order to get to B, you got to go left 1 and up 2. But again, we're going to go twice as far. So we're not going to go left 1. We're going to go left 2, twice as far. And not up 2, but up 4. Again, twice as far. And there are the corners of our dilated figure. Let's try another. Let's do scale factor of 3. So let's dilate this with a scale factor of 3. So to get to A, we go right 3 and up 2, but we're going to go 3 times as far now. Scale factor is 3 this time. So instead of right 3, we're going to go right 3 times as far, which would be 9. And not up 2, but up 3 times as far, which would be 6. 2, 4, 6. To get to D, you go right 1 and down 2, but we're going to go 3 times as far. So right 3 and down 6. To get to C, you go left 2 and down 2, but we're going to go 3 times as far. 1, 2, 3, 4, 5, 6, and down 6. 1, 2, 3, 4, 5, 6. 3 times as far in each direction. To get to B, you've got to go left 1 and up 2, but we're going to go 3 times as far. So it's left 3 and up 6. 2, 4, 6. And there is our figure dilated
Look at what I have.
with a scale factor of 3.
Look at what I got.
Now, what I'd like you to try is dilate it with a scale factor of 4 and a scale factor of 5. So go ahead and pause the video now and dilate that same original shape twice, once with a scale factor of 4 and once with a scale factor of 5. So here's what your shape should look like now. This outer one is a scale factor 5, and this next one in is the scale factor 4. When you do the scale factor of 4, you just go 4 times as far. So instead of over 3 and up 2, you go over 4 times as far. So not 3, but you go 4 times 3, which would be 12. And then instead of going up 2, you go up 8. Again, 4 times as far, and that's how you get there. And each of the points is done the same way. With a scale factor of 5, you go 5 times as far. So instead of going right 1 and down 2 to get to D, you'll go right 5. 5 times 1 is 5. And down 10. 10 times, or 5 times 2 is 10. And that's how we end up there. And you do the same thing for each point. So I've got a question for you. Which of the 4 transformations, a reflection, a rotation, a dilation, or a translation, change the shape of an object? Go ahead and click on the correct answer on your screen. You waited too long to answer. Please click here on the button on your screen to go back to hear the question again. You chose reflection, and unfortunately reflection is not right. When you reflect something, all you're doing is you're flipping it over. When you flip something over like I'm doing with my hand, it doesn't change the size. So reflection is incorrect. You chose rotation, and rotation, unfortunately, is incorrect. When you rotate something, you turn it. Okay? When you turn something like I'm doing with my hand, you don't change the size of the object. You chose translation, and translation, unfortunately, is incorrect. When you translate something, you're just sliding it. Up, down, diagonal, whichever way you're going to slide it. It does not change the shape of the object. My hand, as it slides, is the same size all the time. You chose dilation, and you are correct. A dilation changes the size of an object, as you could see with the activity that we just did. We made this original quadrilateral bigger each time, but it can be made smaller as well, and we'll see more examples like that in the future. That's it for today. We'll see you in class tomorrow. Have a wonderful evening.